Good morning, students. Today we discuss about limitations of Plum pudding model. This model is proposed by, as you know very well, J.J. Thomson. And there is a question. And who discovered that electron? In the sense, if there is a question, you need to write the answer as who is none other than J.J. Thomson. And here we studied already in the previous class. There is a model proposed by J.J. Thomson. That model we are going to call it as Plum pudding model. And the structure of that Plum pudding model, as you know very well, this one looking like a watermelon. And here just you can imagine yourself. Here this is the red part of watermelon, and he told this red part as a positive cloud, or it is acting as a positive charge. And these electrons, these electrons are looking like the seeds of the watermelon, and he told those particles, those are nothing but each and every atom, it is having the shape of like this. And however you are seeing the red part of the watermelon, that is acting as a positive cloud, and the seeds of the watermelon, they are taking, those are called as electrons. Just you can compare the shape of the atom or structure of the atom with the structure of the watermelon. And this model proposed by J.J. Thomson, we are going to call it as a Plum pudding model here. But in day-to-day life, or at the time of Thomson, this model became clever, because as you know very well, this is not the structure of the atom. But here, why this model or why this Plum pudding model became fair here? Some of the reasons are there. Here we are calling those are called as limitations, or you can call those are called as drawbacks. Limitations or drawbacks, both are same. What are those drawbacks or limitations applied to this Plum pudding model? Or J.J. Thomson, what he proposed of this model, there are the limitations are there. What is the first limitation? That is, this model cannot explain about. This model cannot explain about stability of atom. About stability of atom. Stability of atom. As you know very well, what do you mean by stability here? Stability in the sense each and every nucleus or each and every atom have the stability. The word you know very well, stability or instability, whatever it is. But this explained by using this explain, the J.J. Thomson, he cannot talk about the stability of the atom. What is the meaning of stability here? Let us consider. This is the atom. This center part, now we are taking it as nucleus. This is combined with the two nucleons, proton and neutron. If in the atom, if there is the excess number of proton number or neutron number, it becomes excess. Or the nucleus is one proton or neutron. Together we are calling it as this bonding part. We are calling it as a nucleus. In the nucleus, if the proton number becomes excess, or if the neutron number becomes excess, or if there is an increase in the neutron number, or if there is an increase in the proton number, then this atom becomes unstable. Means that if the number of the protons and number of the neutrons, if they are not balancing with each other, or if there is an unbalance in between the number of the proton and number of the neutron inside the nucleus, then that atom we are going to call it as unstable atom. Why it is happening so? Why the number of protons and why the number of the neutrons is become varying? Sometimes the neutron number becomes increases, sometimes the proton number becomes increases. In that case, that stable is unable to balance the number of the nucleons. In that case, that atom we are going to call it as unstable atom. Therefore, why it is happening so? Why there is a variation in the proton number, or why there is a variation in the neutron number, or generally you can ask the question, why there is an instability of the atom? That instability, the reason behind the instability or stability of the atom, that cannot explain by J.J. Thomson or by using this model. That's why this is one of the limitations. Means this model, this Plum pudding model cannot explain about or cannot talk about the stability of the atom also. Means that's why this is one of the limitations. This model cannot explain about the stability of the atom. What is the reason behind the stability or instability of the atom? According by using this model, we can't study or we can't get. That's why this is one of the limitation. And what is the second limitation? That is, this atom cannot explain this model. This model cannot explain about existence of spectral lines. Existence of spectral lines. What are spectral lines? Let us consider, it is the word you are hearing, spectral lines. This model can't explain about the existence of the spectral lines, how the spectral lines are existing inside the atom. What do you mean by here the spectral lines? Let us consider, this is the atom, this is the nucleus, these are the orbits. Let us imagine the electron is present in higher orbit. If the electron is jumping from higher orbit to lower orbit, what is happening? It is releasing the energy in the form of electromagnetic radiation, or simply you can call it is releasing the energy, that energy in the form of light or electromagnetic wave, that is it. Whenever the electron is jumping from higher energy level to lower energy level, or if it is coming from higher state to lower state, then it is releasing excess of energy in the form of light. And if you study the spectrum of this light, or just you can imagine you are keeping one prism here. What is prism? It is an optical device used to split the white light. As you know very well, each and every light has its own spectrum. And here let us consider it is an atom. I consider one of the electron in the higher orbit. Whenever this orbit is jumping from higher level to lower level, then you know very well, then it releases the energy in the form of light. Then our intention is to study the spectrum of this light. Then what you are doing? You are using one of the device, for example, material that is called as a glass material. The glass is nothing but I am using here a prism, because prism, by using prism you can split the constituent spectral of this given light. Whenever this light is incident on this material or this device, then you are getting the spectrum. You are getting the different colors of this radiation. Whenever you are getting the different colors of this radiation, in this spectrum you are seeing number of colors. For example, this is red color or this is yellow color, whatever, these are the number of the colors are there, you are getting on the screen. In that screen, if you getting somewhat there is a black gap in the screen, or a black gap, that line is called as a spectral line. These lines are called as spectral lines because it is the spectrum of, this is the, for example, I am taking it as a hydrogen atom. In the hydrogen atom, what is happening? Electron is jumping from higher level to lower level. Energy is released because of this light. I am producing the spectrum. In this spectrum, the number of the lines you are getting. Some lines are colored lines, some lines are dark lines. Dark line means that is low intensity. Colored lines means high intensity of the light. These lines which are getting in the spectrum, those lines are called as spectral lines. That's it. Spectral lines can be getting by two processes, that is emission spectra or absorption spectra, that is not being by you here. But this spectrum, in this spectrum, some color lines you are getting, that is indicating a high intensity. Some gaps are you are getting. Gaps means dark lines you are getting. Those are called as also spectral lines. All the lines what you are getting inside the spectrum, those lines are called as spectral lines. And this spectrum is called as, for what or by using which atom I am going to producing this spectrum, that is hydrogen. Means this spectrum is called as hydrogen atom. Or if you use that is another, that is for example sodium, then you can call it as a sodium spectrum. That is depending upon which atom you are going to use. And here how these spectral lines are appearing, means how this spectrum is existing. Spectral line means just you can imagine this is a spectrum. How the spectrum is existing. Whenever the electron is jumping from higher energy level to lower energy level, it releases the energy. If you produce the spectrum, how the spectrum is producing, that also cannot explain by using this Plum pudding model. This is another limitation. And third limitation, this model cannot explain. This model can't explain about Rutherford's alpha scattering experiment. This experiment we will see in the next class, that is next concept. There is an experiment that is conducted by one of the scientists who is none other than Ernest Rutherford. He conducted an experiment that is, we are going to call it as alpha particle experiment. We will see in the next concept, that is. This model can't explain about Rutherford alpha scattering experiment. And this is the third limitation. You don't know the Rutherford alpha scattering experiment, we will see in the next concept. And this is also one of the variable. And fourth one, what is the fourth one? Fourth limitation, there is no experimental evidence. There is no evidence about plum pudding model. Simply we are studying in the history, they kept that plum pudding model is kept by or studied by J.J. Thomson. But actually, really there is no some in scientific museums, whatever it is in the science field, there is no actually evidence regarding he studied this plum pudding model. Simply we are studying by using some history books, or in the history books they mentioned that this plum pudding model is explained by J.J. Thomson model. It is looking like this. We are getting in some books, but actually in the science museum or in the science field, we don't have any evidence that this model is given by J.J. Thomson. And this is the conclusion one. There is no evidence about the plum pudding model exactly. But don't consider the fourth one here. But these three you have to remember. First one, very important. Do not explain about the stability of each and every atom, whatever it is the spectrum produced by that respective atom. Second one, this model cannot explain about the existence of spectral lines, means how the spectral lines or how the spectrum is producing, that cannot explain by this model. And third one, that is model can't explain about Rutherford alpha scattering experiment. That experiment we will see in the next concept. And this one, there is no evidence about the plum pudding model that really he explained or experimentally he did that experiment. Regarding that one, there is no any evidence are there. That's why you remember these three. These three are important limitations, that is drawbacks of plum pudding model. And next we will see the concept, that is Rutherford alpha scattering experiment. And the next concept, that is Rutherford alpha particle scattering experiment. And this experiment is conducted by two physicists who are none other than, one is Geiger and another one is Marsden. This is name of the two persons. Actually, these two persons conducted this experiment. But why they kept Rutherford alpha particle scattering? Because these are taking the idea of Rutherford, or they used the explanation or suggestion or the concept of Rutherford in order to keep this experiment. That's why the name came, that is the Rutherford's alpha particle scattering experiment. And these experiment is conducted by Geiger and Marsden. Sometimes we are taking the title as Geiger and Marsden experiment, or else you can call Rutherford alpha particle experiment. And what do you mean by alpha particle here? And what is the intention is to keep this experiment here? That is, in order to study the structure of the atom or the size of the atom, you can call, in order to study the structure of the atom, they conducted this experiment. That's what, by using, this is the arrangement of the experiment here. They use the source, means this is one of the atom or metal. They use the source, that is called as, they use bismuth, that is bismuth 83, its mass number is 214. They use this atom, bismuth atom they use. And next one, that bismuth atom or source that is kept in a lead cavity. Means what is the reason behind this one? Why they use the lead cavity? Whenever the alpha particle is emitting from the bismuth atom, then it should not move in other directions. We need to take the alpha particle in forward directions, because our intention is to hit the alpha particle to the gold coil. Coil is nothing but that is seed. Gold seed. What is the meaning of coil? That is seed, gold seed. That's why in order to prevent the different direction of the alpha particle, they use that is the prevention, that is lead cavity, and both they use the source as bismuth, that is its atomic number is 83 and mass number is 12, and next this is a lead slit. What is the reason? Just to take the alignment of the alpha particles, they use as a lead slit here, and means this is a opening, means their intention should not spread the alpha particles everywhere. That's why in order to take the alignment of the alpha particles, they use the slit as a lead slit, and these are the alpha particles are moving from the atom or source as a bismuth, that is. And whenever the alpha particle is hitting, there is a seed. That seed is made by gold. Gold coil. Coil is nothing but the meaning as gold seed. They kept here in the vertical orientation. Whenever these alpha particles are hitting the gold coil, then these alpha particles, after hitting, they are scattering in different directions. These are all alpha particles. What do you mean by alpha particle here? You know very well. Alpha particle is nothing but that is helium nucleus. You can call it as also alpha particle is nothing but that is helium nucleus. Or else you can call, what do you mean by alpha particle? Let us consider here one atom is there. It is a nucleus. Here is a nucleus. You know very well number of nucleons are there. It is containing protons as well as neutrons. Let us consider, if you are taking out 2 protons from the nucleus and 2 neutrons from the nucleus, then this particle together is called as a alpha particle. Alpha particle is nothing but that is 2 protons plus 2 neutrons together, we are calling it as alpha particle. So means just you can, if you vibrate this atom by using some energy, because of some disturbance, if there is a ejection of 2 protons and 2 neutrons from the atom, that 4 nucleons together we are calling it as alpha particle. Let us consider, I am heating this one, I am vibrating this atom. There is a ejection of one particle. There is a ejection of one particle that is from the nucleus. I am studying, I am analyzing this particle ejected by the atom. Then this particle containing 2 protons and plus 2 neutrons. The total number of the nucleons present in this particle, that is 4. Then this particle we are going to call it as, that is alpha particle. Alpha particle means that is a combination of 2 protons as well as 2 neutrons. That combination particle is called as the alpha particle. Then they use here the alpha particle. You know very well alpha particle, that is having 2 protons and 2 neutrons. That all nucleons together become one particle. That particle is called as a alpha particle. That alpha particle that is emitting from the bismuth, and whenever it is hitting the gold coil, or here gold nucleus are there, whenever it is hitting the gold coil, then after that alpha particles are scattering in all the directions. Whenever the alpha particles are scattering in all the directions, those scattered alpha particles can be detected by using one of the microscope called as detector microscope. Means these spreaded alpha particles are collected by this microscope. And what is theta here? And one more thing here, gold seed they use here. Why they use the gold seed in this experiment? Because the gold nucleus is very heavy. Whenever the alpha particle is hitting the gold nucleus, and the gold nucleus that much easily it is not expressive. Because of heaviness of that gold nucleus, that's why I use the gold coil, and it is very thin, and its thickness is equal to, they used around the thickness of this seed, they used that is 2.1 into 10 to the power of minus 7 meter. As you know very well here in the scientific notation, minus 7 is there, means it is a very thin seed. Its thickness is around 2.1 into 10 to the power of minus 7 meter. That is the thickness of gold coil. And what is the speed of the alpha particle they used here? They are accelerating, or they are moving the alpha particle from the source with the speed, that is kinetic energy is equal to, that is 5.5 million electron volt. With which kinetic energy they are moving? The alpha particle, they are moving with the kinetic energy is equal to 5.5 million electron volt. Means million means 5.5 million means that is 10 to the power of 6 electron volt. With this much kinetic energy, the alpha particles they are emitting the source. The kinetic energy of alpha particle is this much. Whenever they are hitting the gold coil, the thickness of that seed is 2.1 into 10 to the power of minus 7 meter. After hitting the gold nucleus, and those alpha particles are scattering in each different angles. That's why this angle we are going to call it as scattering angle. Scattering angle. What is the angle this is? This is the incident straight path of the alpha particle and the deviation path. In between these two there is an angle, that angle is called as a scattering angle. And those, whenever this alpha particles are coming and hitting the metal here, this metal is made up of ZnS, which means zinc sulfide screen. That is zinc sulfide screen, or you can call it as a detector. Zinc sulfide screen or zinc sulfide detector you can call. Whenever these alpha particles they are hitting this screen, you are getting the flashes. Those flashes is nothing but light. There is a spark is produced. Those can be detected by microscope, and this is the experimental arrangement. And by using this arrangement, they are collected some observations. What are those observations? There is the first observation. That one. And by using this experiment, there are some important observations. They are collected by Geiger and Marston. What is the first observation that is? And here they collected by using detector microscope. They are observing very carefully. Here the maximum number of alpha particles they are moving in a straight line. Means by using this one you can analyze these alpha particles. They are not hitting the here golden periods. Means this alpha particle is moving. Let us consider these are the nucleus of the gold coil. Whenever this alpha particle is hitting the target or gold seed, maximum number of these alpha particles are moving in a straight line. That is maximum number of alpha particles moving in straight line. This is the first observation. And what is second one? That is, it means maximum number means that is 96%. Out of 100, if you consider 100 particles, 99.96 particles they are moving in a straight line. It means that they are not provided with gold nucleus. And what is the second one? Only 0.14%. Only 0.14% alpha particles are deflecting with theta is equal to 1 degree. It means that only 0.1% of the alpha particle they are deviating the path. Instead of straight line, they are deviating somewhat, that to 1 degree. How many particles? Only 0.1% of the particles they are deflecting from the straight path. That to how much degree? That is 1 degree. And what is the third one? And next one, out of 8,000 alpha particles, only one alpha particle is deflected by 90 degree. Is deflected by 90 degree. It means, what is the meaning of this one? Just you can consider 8,000 particles. In that 8,000 particles, all 7,999 particles they are moving in a straight line, and remaining only one particles that is deflecting in more than 90 degree. It means the angle between these two lines is 90 degree. Out of 8,000, if you are observing very carefully, out of 8,000 only one particle is coming back. Means that is the third observation. Next, by seeing these observations, there is an important conclusion is there. That conclusion we'll see in the